Hello everyone. In this video we're going to be simplifying a numerical expression. We have 100 to the power 100 divided by 50 to the power 50. So these are exponential expressions and these are very large numbers. I'm also going to be showing you some numerical values from Desmos as well as Wolfram Alpha. So let's go ahead and simplify this. We can do it in a couple of ways. First of all, notice that 100 is 2 times 50. So we can go ahead and write it that way. Write the 100 as 2 times 50 and raise it to the power 100. And then divide it by 50 to the power 50. And then we can go ahead and expand it by using a common exponent. This is 2 to the power 100 multiplied by 50 to the power 100 divided by 50 to the power 50. Great. Now we can go ahead and work these two together because they have the same base. So all we have to do is subtract the exponents. 2 to the power 100 stays. And then from these two things, we get 50 to the power 50 because 100 minus 50 gives us 50. So you can leave it at that if you want, but I'm going to do the following. I'm going to go ahead and write the 2 to the power 100 as 2 to the power 50 times 2 to the power 50. Because 50 plus 50 is 100. And then I'm going to go ahead and combine these two together because 2 times 50 equals 100. So I can write it as 2 to the power 50 times 100 to the power 50. And 100 is 10 squared. So I can also write this as 10 to the power 100. Make sense? So we can go ahead and simplify our expression that way. That's kind of one way to look at it. Let's go ahead and take a look at another way to look at it. Okay. So we have 100 to the power 100 divided by 50 to the power 50. Now in our first case scenario, we kind of put the 50s together because those two numbers had the same base. Can we take advantage of something like the same exponents? And yes, the answer is yes, because we can write the 100 to the power 100 as, you know, something like 100 to the power 50 times itself, right? Because 50 plus 50 equals 100. Great, so we didn't change the base, we changed the exponents. So now go ahead and divide this by 50 to the power 50. And then from here you're going to be able to combine these two things because they have the same exponent. Last time it was the same base, this time it's the same exponent. And what is the rule? If you have a to the n divided by b to the n, you can write it as a over b to the power n. The first time we used a different formula, it was kind of like a to the power n over a to the power k, and it was a to the power n minus k. Okay, same bases or same exponents. So those are the rules. And now we're going to get from here 100 to the power 50 is going to stay. And then by dividing these two, basically we're dividing the bases, right? 100 divided by 50 is equal to 2. And then I use the common base, which is 50. That's how the rule works. Great? Okay, cool. So that kind of brings us a different result because we can kind of combine these two things. But let me go ahead and turn it into the first solution first, and then we'll do the other one. So I can kind of write this 100 as 10 squared to the power 50, and then I can multiply the exponents because the rule says a to the power x to the power y can be written as a to the power xy. Again, another property of exponents, which is important. And then we get 10 to the power 100 times 2 to the power 50, just like before. Same thing, right? But we could also do the following. We could get a different result, which is actually kind of cooler because that allows us to write the whole thing as a single expression. So we got from here 100 to the power 50 times 2 to the power 50. Make sense? Okay, here's what I'm going to do. Remember, one of the rules said if you have the same exponent, you can combine the numbers. How? A to the n, b to the n, a times b to the n. So we can use a common exponent here. So write this as 100 times 2 to the power 50. And that can be written as 200 to the power 50. Interesting, right? Well, what is that supposed to mean? It kind of gives us another option too. 100 to the power 100 divided by 50 to the power 50 is equal to 200 to the power 50, because when you multiply these together, you get 10,000 to the power 50, which can actually be written from here, right? You can kind of go ahead and write this as 10 to the power 200 and then divide it by that, and you'll get pretty much the same result. Okay? So in other words, this is what I'm trying to say. This kind of gives us a third option. I can go ahead and write this as 10, 100 to the power 100 can be written as 100 squared to the power 50 divided by 50 to the power 50, and then this becomes 10,000 divided by 50, and then raise it to the power 50, and you get the same result as this one. You could also approach this problem as 2x to the power 2x divided by x to the power x and simplify it in different ways. And this doesn't bring us yet to the end of the video, because I'm going to show you some numerical values. Here's one of the values that you can find from Wolfram Alpha, Desmos. And Wolfram Alpha gives us the following, and also a beautiful name, which is 11 septuagintillion. It's kind of hard to say, but it's also much bigger than a Google. And this brings us to the end of this video. Thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you tomorrow with another video. Until then, be safe, take care, and bye-bye.